When a scorching summer hits, what's our go-to solution? We crank up a complex, power-hungry machine that hums outside millions of windows. It's a technology that accounts for about 10% of all global electricity consumption. But when the grid gets strained, when the power flickers and dies, we're left completely helpless against the oppressive heat. Now, imagine a civilization that didn't just survive, but actively thrived in 115-degree desert heat. A civilization that built sprawling, comfortable oases for thousands, all without using a single watt of electricity. They didn't have our tech, but they had something far more valuable. Something we've mostly lost. An ingenious understanding of natural engineering that let them build ancient air conditioning. What if the real solution to our modern cooling crisis isn't in the future, but buried deep in the past? To find these answers, we have to travel back in time to the heart of the ancient Persian Empire, to a city that looks like it was sculpted right out of the desert floor. Yazd. For centuries, this city, now a UNESCO World Heritage Site, has been a masterclass in sustainable living in one of the world's most extreme climates. Its people faced blistering summer days and frigid desert nights, yet they engineered a level of comfort that feels almost like magic. Their secret wasn't one single invention, but a brilliant, interconnected system. And it all starts with the most iconic feature of the city's skyline, the towers. These aren't just decorative chimneys. They are Bādgir, or Windcatchers. For thousands of years, these structures have been the silent, power-free engines of the city's comfort. A windcatcher is a marvel of effective simplicity. It's a tall tower with openings at the top, designed to catch the cooler, faster-moving breezes that blow high above the dusty city streets. As the wind is caught, the tower funnels it down into the rooms below. This downward pressure forces the hot, stale air inside the home to rise and get pushed out through another opening on the other side of the tower. But here's the crazy part. Even on a completely still day, the system still works. The sun heats the air inside the chimney-like structure, causing it to rise. This creates a pressure difference that pulls cooler air up from inside the house, which in turn draws fresh air in from a lower opening, creating constant, gentle circulation. Studies have shown this simple design can drop indoor temperatures by a remarkable 8 to 12 degrees Celsius. But the Windcatcher was only part of this elegant system. To make it even more powerful, the architects of ancient Persia combined it with another piece of engineering genius, one hidden deep underground, the Qanat. A Qanat is a subterranean aqueduct, a gently sloping tunnel that can run for miles, tapping into underground water from the mountains and carrying it to the city. This alone was a monumental achievement, giving them a reliable source of water that was protected from evaporation under the brutal desert sun. But its function went way beyond simple irrigation. Here's where the true brilliance kicks in. Many of Yazd's grandest homes built their windcatchers directly over the path of a Qanat. Now, the air being drawn down wasn't just circulating. It was being pulled across a current of cold subterranean water. This process, known as evaporative cooling, supercharged the whole system. As the hot, dry desert air passed over the water would evaporate, absorbing a massive amount of heat from the air. The result was a steady stream of naturally chilled, humidified air delivered right into the heart of the home, a true power-free air conditioner. This integrated system of windcatchers and Qanats created unbelievably livable spaces. But what if you wanted more than just cool air? What if you wanted to completely defy the desert? What if you wanted ice in the middle of summer? For that, the Persians had one more trick up their sleeve, and it's arguably the most astonishing of all, the Yakhchāls. Dotted across the Iranian landscape are these strange, conical mud brick domes that look a bit like alien beehives. For centuries, these structures were ancient refrigerators, capable of not only storing ice through the hottest summers, but, in some cases, even producing it. It's a feat of physics that seems to border on sorcery. The process started during the cold, clear desert nights of winter. Water, often supplied by a nearby Qanat, was channeled into shallow pools right next to the Yakhchāl. These pools were often shaded from the sun by a long, high wall. At night, even if the air didn't drop below freezing, the principles of radiative cooling took over. The water in the shallow pools would radiate its heat away into the clear night sky, allowing a thick layer of ice to form on the surface. Before sunrise, workers would break up this ice and carry it into the Yakhchāl's massive subterranean storage pit, which could be up to 6 meters deep. Layer upon layer of ice was stored, often separated by straw to keep the blocks from fusing. Then, the structure's passive genius took over. The dome was built from a special super-insulating mortar called Sarooj, a mixture of sand, clay, egg whites, lime, goat hair, and ash, creating walls up to 2 meters thick at the base. This incredible thermal mass acted as a nearly impenetrable barrier to the sun's heat. The dome's conical shape was also totally deliberate, minimizing the surface area exposed to the high sun while helping radiate any absorbed heat away more effectively. An opening at the very top allowed any warm air that did get inside to rise and escape, while the deep, cold pit kept the ice frozen. Some Yakhchāls even had windcatchers to draw air over the ice, using evaporative cooling to lower the temperature inside even further, making them astoundingly efficient. This combination of smart physics allowed them to maintain sub-zero temperatures and keep ice available all year long, ready to be used for chilling food and creating ancient Persian desserts like faluda. This mastery of the elements wasn't just a Persian thing. Across the ancient world, different civilizations, faced with their own unique climates, independently developed brilliant ways to beat the heat. In ancient Egypt, wall paintings from as early as 1300 BCE show buildings with tall ventilation shafts called malkaf, an early type of windcatcher designed to channel the cooler northern breezes down into homes. On a simpler scale, Egyptians would hang wet reed mats in doorways. As the dry desert wind passed through, the evaporating water would cool the air, providing a refreshingly simple air conditioner. The Romans, who were masters of plumbing, turned their legendary aqueducts into cooling systems. In the most luxurious villas, they'd engineer a network of channels inside the walls and floors. Cold water from the aqueducts would circulate through these channels, absorbing heat from the building's structure and lowering the indoor temperature, a primitive but effective form of radiant cooling. Their atriums, with an opening to the sky and a pool on the floor, also acted as climate engines, letting hot air escape while the water provided evaporative cooling. And in China, as early as the 2nd century BC, engineers developed manually powered rotary fans. By the Tang dynasty, these were scaled up into enormous water-powered fan wheels installed in imperial palaces, creating what was described as a constant cool breeze for the emperor. From the elaborate systems of Persia to the simple wet reeds of Egypt, these cultures prove that our ancestors weren't just passive victims of their environment. They were keen observers and brilliant innovators who understood the physics of heat, air, and water in ways we're only now starting to appreciate again. For decades, these ancient techniques were seen as little more than historical curiosities. But now, as our modern world grapples with rising temperatures and an energy crisis, architects and engineers are looking to the past for inspiration. This lost wisdom is being rediscovered and re-engineered for the 21st century. You can see it in action at the Zion National Park Visitor Center in Utah. In a climate where summer temperatures regularly soar, the building's cooling solution uses 93% less energy than a conventional building of its size. It pulls this off not with massive air conditioners, but with passive design principles straight out of the ancient playbook. It uses thick masonry walls to create thermal mass that absorbs the day's heat and slowly releases it at night. Downdraft cooling towers, a modern take on the Windcatcher, catch hot, dry air, pass it through water-moistened pads to cool it, and then let the dense, cool air fall silently into the building. Further afield, in the United Arab Emirates, Masdar City is a stunning experiment in sustainable design. The city is oriented to funnel prevailing winds through narrow, shaded streets, creating a microclimate that can feel up to 10 degrees Celsius cooler than nearby downtown Abu Dhabi. Buildings are clustered to shade each other and feature modern versions of latticed screens that reduce heat gain, a technique seen in ancient palaces. Recently, Masdar has even started using geothermal energy from deep underground to help power its cooling systems, a modern spin on using the Earth's natural temperatures. Even the ancient Qanat is being reborn. In Seville, Spain, an architectural experiment called Qanats uses a network of underground pipes and solar-powered pumps to cool public spaces, reducing temperatures by as much as 10 degrees Celsius. These projects prove that ancient wisdom and modern technology aren't at odds. They can form a powerful hybrid, creating buildings and cities that are not just more sustainable, but more resilient and more comfortable. The air conditioner has become a symbol of modern comfort, but it's come at a steep cost to our planet and our power grids. The ancient engineers of Persia, Egypt, and Rome show us that there is another way. They proved that with a deep understanding of nature, you can create harmony with the environment rather than just fighting against it. Their windcatchers, water channels, and ice houses aren't primitive relics. They are a legacy of genius, a testament to a forgotten wisdom that understood how to build for the climate. As we look to build the cities of the future, maybe our most important innovation will be to look back to learn from these masters of the desert, and to remember that sometimes the most sophisticated solutions don't require any power at all.